Hi everyone, and welcome to the second session of Digitodontics webinar series. This is Mahmoud Al-Bashti with you today from Digitodontics International Academy. It's our pleasure and honor to welcome our guest speaker, Dr. Abdulmajeed Okshah from the University of Tübingen, Germany. Dr. Okshah will share with us his experience in digital dentistry, an overview from data acquisition to manufacturing. Dr. Abdulmajeed was graduated with the BDS degree from the King Khalid University in Abha, Saudi Arabia in 2011. Then he was appointed as a teaching assistant at the Department of Dental Technology at the same university. Within this period, he also served as a dental surgeon in Asir Dental Hospital within the dental center. From 2014 until 2016, he was a guest scientist and resident of the Perioprostodontic graduate program at Freiburg University, Germany. In October 2016, Dr. Okshah joined the postgraduate program of prosthodontics and implantology at the University of Tübingen, Germany. In 2017, he obtained the German fellowship and board for dental technology at Kiel University, Germany. In 2018, he obtained a Master of Dental Science, MDCS, in prosthodontics and functional dentistry with excellent grade at the Medical University of Vienna, Austria. In 2019, Dr. Okshah was accepted as a doctoral student at the University of Tübingen in Germany. In the same year, he also awarded a certificate as expert in digital dentistry at Munich University under the supervision of Professor Dr. Daniel Idholf. In 2020, Dr. Okshah finished the specialty program of sport dentistry organized by the German Society of Sport Dentistry, and he was awarded the certificate of team dentist. In 2021, he was awarded the certificate of the fellowship of the maxillofacial prosthodontics at the Department of Prosthodontics and Oral and Maxillofacial Surgery, University of Tübingen. In this year, he finally submitted his doctoral dissertation and waiting for the defense at the same university. So just before Dr. Abdulmajeed start his presentation, I would like to raise your attention that you can write your questions on the Q&A section. And once Dr. Abdulmajeed finish his presentation, he will be happy to answer those questions. So without any delay, let us once again welcome Dr. Abdulmajeed Okshah. Abdulmajeed, I'm so happy to having you with me.
Thank you very much. Should I share my screen or it's already shared?
No, it's already shared, so you can start your presentation. So the stage is yours, please.
Thank you for your nice words, and the honor and pleasure is mine. Actually, I'm very honored to be selected among your esteemed speakers in this esteemed academy. Thank you very much for hosting me and for inviting me. I will try to make my presentation as fast as possible because of the match today. So many people are asking me to finish early and or all of my wishes to Moroccan team.
Thank you.
At the beginning, I am not promoting any product or any institution. I just wanted to point that I am working in University of Tübingen, and I have support from the Competence Center or Center of Additive Manufacturing, which is one of the most leading centers in the additive manufacturing in the world. Before I start, I wanted to tell you a story which happened a few weeks ago. I was in a meeting or dinner at the work, and we met here Mr. Kovarat. Mr. Kovarat, he was the master dental technician and the leader or the manager of the dental lab, and I asked him, how do you see dental technology? He was silent and he did like this for a few seconds. Then he looked at me and he said, Digitalisierung, which means digitalization. In my opinion, digitalization is not the future of dentistry, it's the presence of dentistry. We are living this one. It's not something in the future. We are living nowadays. And he said something very important, communication between the dental lab and the clinic is very crucial in success of our restorations. If we want to be successful prosthodontists, whatever, in my opinion, whatever you want to be successful in your life, you have to work on your communication skills. That's why communication is very crucial and important. If we look to the International Journal of Prosthodontics, and we see the cover page of this journal in 2018. In the 2019, they changed their mind. 2022, we see they are going to this direction of digitalization. It means digitalization is changing the whole world, not just the dental world. As we talked before, and you told me to present something about digital dentistry, I was thinking digital dentistry, it's two separate words. We have to talk about digital, what is digital? Then dentistry. Dentistry, it's the practice of dentistry which which is the platform of all of us in this room. But what does digital mean? But before I try to split this one, I wanted to congratulate you for choosing the name Digitodontics. It's the best name actually for this academy because it combines both of these terms in a nice way.
Thank you, Abdulmajeed. Thank you.
You're welcome. This fellow, the one who destroyed our world nowadays, I didn't knew that in the wings, these are fingers. The word digital came from a Latin word. It's a Latin, and it comes like digitus and digiti, which is the plural of the digitus, which means fingers. It was in the Egyptian also, in the Egyptian era and in the Latin era, it was measuring unit. For example, if I wanted to say how tall is X man, we say he's maybe 50 fingers. It was like measuring unit. That's why there are some people in our, like nowadays, they are thinking that digital dentistry is the dentistry of using your hands. And this one is really true because last weekend, I was in Frankfurt, close to Frankfurt, in a city called Bad Homburg, in a conference for functional dentistry. And there was a professor, and he said, I don't believe in machines. I believe just in my hands and hands of my technician. I don't like digital dentistry, what we call digital dentistry. That's why he's thinking in digital dentistry is what he's doing with his fingers. I respect his point of view, but we have different point of view, what we will share today, which is we can call it computerized dentistry, digital dentistry or computerized dentistry. Why did I share this slide? It's the language, as I said in the beginning, is communication. The communication between you and your computer through a language. And the language that the computer understands is 0-1 language. This is what we call computerized or digital dentistry. We will talk, or we will continue our talk today about this topic, not about finger dentistry. I cannot say digital dentistry is the best thing in the world or analog is the worst thing in the world. No, we may combine both of them. And for example, if you have Rolex watch, you cannot say it's bad because it's analog. It's worthy. And you have the option either to work with this or to make combination. In my opinion, the best thing is to make combination of both of these technologies. The scopes of digital dentistry is very broad. I will start with documentation. One of the causes which made me take longer time for my doctoral thesis, is this thing. Because I had to go to the patient files since 1900 something, and I have to go to the archives and to see the patient cards to read all of them. I found really so many difficulties. If it would have been digitalized, my life would have been easier and I would finish very fast. But this is something that the digital world is offering, and it's related to digital dental technology. Also, when we think about photography, before we used to have cameras with films and take these films in machines and to take the photo, and later on we transfer them to the computer. Nowadays, it's much easier with better accuracy, with better timing and everything. If we take radiography as an example, we have what we call a CT scan, which is computerized dentist tomography, which we use when we started using computers in radiography. We use it in dental world, especially in dental implants, for example, in the planning of dental implants with the help of CBCT. Also, we can use them for diagnosis. We use them in orthodontics. We use them in endodontics, in periodontics, in all fields of dentistry. Now we'll talk about orthodontics. I think I don't want to make any problem with any colleague from orthodontic world, but I think the future of orthodontics is in danger with the align therapy. That's why it's becoming very fast, and we see it nowadays. In Germany, we have a company called Dr. Smile. They will send you to your home silicone. You put your silicone for yourself, send it to them. They will send you the aligners, which is not good in my opinion. I will not promote this one. We'll talk now about computer-guided endodontics. It made the world of endodontology very easy for the endodontist. It makes the failure rate, it will decrease the failure rate of the therapies. Last but not least, what we'll talk about, it's my specialization, which is prosthodontics, which we'll talk a little bit today about. Before we talk about this subject, we have to go back to the history and see where it has started. I cannot say it's old. I cannot say it's new technology. It's relative thing. For some people, they say, oh, it was almost 50 years ago. It is very old. And for others, they will say it's modern thing, which is just 50 years ago. It's a relative thing. But it started with this fellow, the Professor Dr. François Doré in France, who started in early of 1970s in this field. I was pleased to meet him many times, not just one time. And this time it was very unique because this is Professor François Doré. And this one is Professor Moorman, the one who invented CEREC system. In the literature, most of the literature will say it started in Zurich University and with CEREC system, but it was starting, it started a few years ago or before the invention of CEREC in France with Professor François Doré. He even wrote his doctoral thesis in 1973. I think if I still remember when he presented, and it had the name, I don't know if I can pronounce it nicely in French. You may correct me. L'empreinte optique, or the optical impressions. This is Professor François Doré in his lab, and this is Professor Moorman with Dr. Engineer Marco Brandestini, who invented the CEREC system in early 80s. The digital dentistry, it has components, and it's like workflow. Where it start with computer-aided inspection, or how to acquire the data, which we will start to, it was the title of the presentation, from acquiring the data, when we acquire the data, till manufacturing. The first step, we have to collect data. To collect data, we have so many options. We have to start with intraoral scanners, for example. We have some devices to make, like our jaw relationship, which is called digital occlusion, which I really like. This is my field, and I have done so many courses in this field. We have the lab scanners, we have CBCTs, we have also photos. All of these things are information that we gather at the beginning to go to the second step, which is we call the blueprinting or the designing of our restoration. We do the planning of our prosthetics, implants. We do data matching if we have CBCT, for example. And at the end, we make the design of our restoration. After we have our restoration designed, then we go to the creation, which is the manufacturing. In this manufacturing, we can differentiate between subtractive manufacturing and additive manufacturing. We'll talk about them in a bit. The scanners, we have to differentiate between two types of scanners. We have to differentiate about the first thing, which is intraoral scanners, which I think it has to be in every clinic nowadays. Or sometimes we have to make impression to have our model, analog, and digitize this model in the dental lab with the help of dental lab scanners. On the other hand, we have extraoral scanners, which is scanners for the face. We have some devices to make the facial scan, or we can make it with our mobiles. I have to announce this application we cannot buy anymore now with Apple Store. It was till I think 1 year or 2 years ago it was available, but nowadays it's not available. There are so many other applications, or sometimes it's included in new iPhones. We can use it. This is an example of a device we can use. This one called Cypress from company. This one I made the course with the company Amangerbach. And I try usually to make pictures of myself, because I try to put the device on myself to try it before I try on the patient. Then I know how it feels. Sometimes I remember my first experience with axiography. It was with Cadix in 2014. I almost cried because it was very tight, very heavy for so longer time. I had, because with the training we needed a longer time. Then later on you will understand the patient's feeling. That's why I try to test every device or most of the things on myself before I try it on the patients. With these devices, we have the ideas of our occlusion, with the relations with the temporomandibular joints. When we want to manufacture any occlusal splints, these are, or big restorations, these tools are very helpful. Another example of these things is this amazing device from Titan company, which measures the muscles. You can have an idea about the occlusion of the patient and the muscular disorders in a few seconds. After we collect all of these data, we have to send them to the computer. To send them or transfer these data to the computer, we have so many formats. The first format, which is STL files, which state to standard tessellation language or triangle language. I learned something a few months ago, that this format, I don't know, in German we say ungeschützt format, which is not secured. I don't know if I translate it nicely. but which means these data, it's in a form of triangle, but it's different from one device to the other one because it has these shapes. We have so many different shapes of triangle. If I say I have 200 tables, it's exactly like this one. I have big table, small table, table with 2 legs, with 4 legs. This is different. That's why in 1990s they started with a format called PLY file, which is more precise because it will transfer the data in a shape of polygons, which is the chances of failure are less. Or we have OBJ format, which is similar to PLY with some color features. I will advise you to go to this article, which is really nice, very short article from the company Mediate about these different formats. Why do we need 3D data? Why is it important for us? If I have this photo, for example, I will read this information, just do nothing. Or on the other hand, also I can say it's impossible, which is negative thoughts. But if I have the complete picture or the 3D picture, then I can understand the whole sentence and think positively. That's why we need always to have the whole picture to judge. And to have this whole picture, we need these 3D data to be very precise and very nice and very clear. Especially if I wanted to do intraoral scanner and I have blood or I have saliva and they say it will be corrected by the software, which is not true. We have to deal with these intraoral scanners with precision to have the precise image, then we can produce precise restorations. After we collect this information, we have to design our restoration in the computer. We have two different types of softwares. We have closed softwares which belongs to some companies, and you cannot use the software for other companies. You get the data, you'll stay within this system and finish your restoration from data acquisition till manufacturing. You'll stay in the same system. Whereas we have the open system, which is open systems that they can gather information from different scanners, will do the design in this software and send it to another manufacturing unit, which doesn't belong to the same system. My advice is that if you start with a system, to focus on the system and to learn, because you have to develop your learning curve. At the beginning, everything needs learning curve. I cannot say I'm expert in X system and I can do the other system perfectly as good as I do this one. Then if you start with a system, start step by step and be patient, because you have to develop your learning curves. After we finish the design of the restoration, we have to send to manufacturing. In the manufacturing procedure, we differentiate between subtractive manufacturing and additive manufacturing. Subtractive manufacturing in the means of milling machines, like what we see here, or in 3D printers, as we see in additive manufacturing. We will start with subtractive. We have to differentiate between both of them. As a general rule, we start with small quantity and build up. We build them up step by step, layer by layer. Then we have additive manufacturing on the left side. On the other side, we have an object, and we have to decrease the size of this object to have the final restoration that we need. This is the difference, the main difference between them. The main disadvantage of subtractive manufacturing is the waste is more than the waste which is produced by additive manufacturing. The materials that we use for additive manufacturing will come in mainly in three main forms. The first form, which is a liquid form, which will be later on photopolymerized. The second thing, which is powder. We have two different kinds of powders, and the third thing, which is thermoplastic materials. Whereas the subtractive manufacturing combine so many materials like waxes, composite ceramics, alloys, and etc. We will start with subtractive manufacturing, which is, we say always CNC, which is computerized numerical centers, which is a system will give some orders to the electrons, the electronic system to start the procedure. We have to differentiate between two procedure. The first one, which is milling procedure. The second one is grinding procedure. The milling procedure we have to use, I'll make it as simple as possible because my goal of this lecture or my target group is to keep this information to the beginners of the field, especially dental students or beginners to have a real overview. We start like with a carbide bear. If we use a carbide bear, we say it's milling. Whereas if we use diamond bears, we call it grinding. Or another word, this is a bear we got from the company Comet. If you have defined geometry of the instrument, then you are doing milling. And this one called Lindemann Fraser. This one is an example of this bird. We also can differentiate between dry and wet manufacturing, or milling or grinding, depending on the material that we are using at the end of. If I wanted to make zirconia, we usually do dry milling. If I have to, or I want glass ceramic, for example, any crown, then we make wet grinding. This is an example of dry milling, and this is an example of wet grinding of ceramics. Sometimes with some metals, like with titanium, sometimes we use water. We have to make it in wet environment. The milling machines are different. It depends upon your use. For example, you have small machines which you can use in office or chair side machines, or you can have some machines in the lab. You have to also sometimes. I am a guy who's doing just all ceramic illustrations. I will use some materials or some milling machine which suit my purpose of my treatments. If I am a person who is doing a lot of implants and big illustrations, and I need to do a milling of titan bars or abutments, then I have to use the other machines. It depends upon the person's preference and his use. Now we will talk about the additive manufacturing, or we call 3D printing. We have to divide them to, there are so many classifications in the literature. I like this article. I would like you all to have a look about this article. It's really nice, and the group are a very strong group from Munich University. We have SLA or DLP printers, for example. We have binder jettings. We have selective laser melting and selective laser sintering procedures, and we have FDM procedures. If you want to classify them in another way, we can define we can say the materials, depending on the material. If I have some liquid materials, I need to do photopolymerization, then we put them in the first group. With this first group, we have different type of printers like LCD printers. I didn't talk about all of them because of time. Because of the time, I cannot talk about. We need just one lecture or one webinar about 3D printing. That's why I try to compact all of information in the same presentation. As I said, the first thing, which is photopolymerization, we have SLA DLP printers or LCD. We have the second criteria, which is powder bed fusion. We have so many things, but for the most important thing, or the clear the most used things are binder jetting and selective laser melting and sintering, and the fused deposition manufacturing, which is by using the material extrusion. We'll talk about them one by one. The workflow of additive manufacturing, we do as usually, we do scan, either intraoral or scanning of our analog models. Then we do design. After we do our design, with our design software, we have to do slicing of this design to make it. If we have this object, for example, if I wanted to make denture base, for example, we have to cut them with the software to slice them to small slices to fit to the criteria of my printing. Then we send them to the printer and it will start the printing. After I got the printing, the printed object, I have to wash it in isopropanol. After I wash my object, I take it to the curing unit or photopolymerization unit with ultraviolet light. And at the end, we have our end product. This is a small idea about what I have said. This is the scan. It's not related to each other. It's not the same case. And some pictures I got from Labs website. This is our design. This is our scan. This is the design. This is how do we do the slicing and to do the pins to do supporting of the printing object. This is the printer, for example. This is the washing unit, and this is the curing unit. And these are examples of end products or restorations that we can use. I learned something during my search for this topic, that we can do 3D printing of chocolate. It was a very new thing for me. I didn't know that we can do it. I think in the near future, we do 3D printing for everything. The first type of photopolymerization technique, we start with stereo lithography, which is SLA. This is an example of a printer. It started this technique in 1984 by Charles Holz. It was the firstly commercial introduced technique to the market. I think, according to my search, the first publication was in 1994, I think in Japan, with removable prosthesis. It was done by 3D printing procedure. This machine is using laser beams as a light source, and it will print the object pixel by pixel, point by point. That's why the accuracy of this one is very high. If we'll talk about the thickness, the accuracy is high, but we have to take in consideration it will take longer time than other techniques. The thickness of my printed layer, it will be around, it will start from the 25 till 150 microns, which is with 25, it's very acceptable. We are in the very acceptable range. And we have to take in consideration that we need to do post-curing or processing polymerization after we print the object. These machines are relatively expensive in comparison with other techniques. These are some examples of some cases. This patient came to me. I have done obturator. This is my prototyping. Unfortunately, it didn't pass for this patient, and the patient was not in a very well state. She was fragile, and we didn't want to pursue more, and we went to the analog technique at the end. But this is an example. It was one of my first cases, and this is also one of my first cases with 3D printing, with not long-term provisionals. It's with short-term provisionals. This is an example of denture base and denture teeth we printed. Then we will bond them later on, and this is prototyping of one complete denture also. The second technique with the photopolymerization, it is digital light processing or DLP. It has the same concept with polymerizing liquid resin. It utilizes ultraviolet light instead of laser and projector. The projector, it's the same concept of the projectors that we use in the lecture halls, in the same exact concept, but it's smaller with high accuracy. It prints the object layer by layer. It has good accuracy, but decreased time in comparison with the laser, with the SLA, stereolithography. The thickness of the layer is the same like the other one, and we have to do the same procedure with post-curing. This is a case of my colleague, Dr. Pablo Fernandez Crema. He published in a Journal of Prosthetic Dentistry at the beginning of this year. And I really liked his idea of digitalizing the whole technique from intraoral scanner, although it was very difficult in this case. But he invented some technique. I will advise you to see his technique in his article. It was very interesting. How did he manage to make this obturator? The indications of SLA and DLP is the same. It's based on this article from our group from Competence Center in the university. We have to divide them to three main indications ranges. The first one, which is the things that we do in the dental lab or clinical aids, which should not stay for longer time in the patient's mouth. The second thing, which is the short-term restorations, and the third one, which is the definitive restorations. Examples of the dental lab and clinical aids, special trays, surgical guides, models, burnout waxes or polymers to put them in the oven and to do casting, or sometimes to do pressing for ceramics and other kinds of splints we can use in orthodontic surgeries. We have also the short-term restorations like occlusal splints or provisionals. In my opinion, we will not use occlusal splints as an indication of short-term of SLA or DLP. Usually, we use milling of the occlusal splints rather than 3D printing because of the material. I don't know the name in English. Eigenschaften, which is characteristics of the materials. The definitive restorations, an example is complete dentures and obturators. This is just examples. To differentiate between SLA and DLP, I found this nice picture. This one is the laser beam will go, and this, if we have this resin liquid, it will make curing of it point by point. Then we can imagine how much time it will take if we take this point, then this, then this, then this. It will take time, especially we are talking about X, Y, Z axis. And this one is this one is ultraviolet source. This is the projector. It will make the light spread. And we have our restoration cured layer by layer, which is faster. The third technique, which uses material extrusion technique, is called fuse deposition modeling or fuse filament fabrication. We heat the material. I'll make it as simple as this. We heat this material. We have the platform, and we start to put the material step by step, layer by layer, to construct our object. The thickness of this one is thicker than the others. That's why the accuracy is less. And we don't need, this is something positive about this one, we don't need post-curing procedures. If we think economically, this one is cheaper than the others, but in the range of indications, it's limited because of the accuracy and the properties. This word I wanted to find before, the mechanical properties of the materials. This is an illustration of how it works. It will work step by step and layer by layer to make our final object. One positive aspect of this one, if we want to make hollow objects or objects like this one, we can make it very easily with 3D printing instead of making this one with milling techniques, with subtractive techniques. These are the range of indications. In my opinion, we can use them like for models, especially for orthodontic models, special trays. These splints, it's, in my opinion, it's not indicated for splints, but we can use them as interim prostheses. And we have a work was done in the clinic, and it was published by my colleague Moritz Mochla. This one, Valplast denture, which is the flexible dentures, was done by this technique. This is a small video about this prosthesis, how it was done. And this is these photos are from his publication. This is an example of, I wanted to show you how flexible the material is. I hope it will work, this video, yes. You see how flexible these materials are. It's not also very hard. And we see the accuracy of this model. It's not very precise. It's not very accurate. Then we cannot use it properly in prosthetic treatments. We will talk about the last point in additive manufacturing. For example, today we have selective laser sintering and selective laser melting. In general, the technique, it works like this one. We have a powder and we put a laser, power of laser, to make this powder, to make them connect to each other and to be solid. This is the whole concept about of this technology. We differentiate between sintering and melting. The melting, the laser, it has higher power, and it will melt the particles of the powder. When they melt, they will join each other, they will combine with each other, and it will, or we can call it consolidate, and we have at the end our object. It will be solid at the end. One advantage of this technology, we don't have oxidization, we don't have any oxide layers. It's very clean, and there is no porous in this with this technology. With the sintering, we have the powder in pre-sintered stage. We sinter them with the laser. The power is below the melting temperature, and to make sintering of these particles by the use of laser. Usually, we have different materials with selective laser sintering. Sometimes we use ceramics, polymers, peaks. While with selective laser melting, it's usually with metals. There are some people, like some companies, they're using this one also for gold, to make gold rings or any kind of jewelries. They make them with selective laser melting, which is very precise. These techniques, the binder jetting also, we have also a technique called multi-jetting. These techniques are not used in the small dental lab. We have to use them in industry. And one of their disadvantages is the cost. It's very costly, these devices. We can also, sometimes we do a hybrid technique. We do our restorations with selective laser melting. At the end, we do, for example, in big implant cases, like with the hex of the implants, then we do milling of the hex without touching the framework. This is an example. The indications of selective laser melting and in removable partial denture, the frameworks, we can use them in double crown techniques, which is very famous in Germany. We can do implant abutments or fixed dental prosthesis also. This is how it looks like. This is a publication from Dr. Strezel from company Vigo. This one from company Fugini, it's Italian company. And this is a small video from the company Vigo, how it works. This one, we have this one and a layer, and it will make curing of these particles with the laser, and it will build them layer by layer till we have our 3D object. I think I'm almost done. I will make a small conclusion about our talk today, the components of digital dentistry. We start with computer-aided inspection or acquisition of data. We differentiate about intraoral and extraoral procedures, and we can use two different procedures either in office or in the dental lab. The second component, which is computer-aided design, we differentiate between open and closed systems. And we said you have to think in the future, or when you start your career with designing, my recommendation is to stick to the system and to learn the basics and to have your learning curve. The third the third component, which is the computer-aided manufacturing or creation of the prosthesis or the objects, we differentiate between subtractive and additive methodology. The subtractive, we differentiate between milling and grinding. Milling, if we have defined geometry of the instrument, then we say milling. If we have undefined geometry or like diamond burrs, we say grinding. It has nothing to, we have to differentiate. It's not the same like wet and dry. It's completely different because sometimes we can do wet milling, for example, with titanium. Sometimes with zirconia, we do. The additive technique, we have three main techniques: the photopolymerization, which is polymerization of liquid materials; the powder bed fusion, which is we have a powder bed, and we do curing or joining these particles either with laser, for example, in by the means of selective laser melting and sintering, or binder jetting. Binder jetting, I didn't talk about. It's like if you have the powder and you put some liquids, we'll make it as simple like bonding between all of these, which is called binder, to bind these particles to each other and to form the subject. The material extrusion, which is the cheapest, was one of the cheapest techniques in 3D printing. It's not very accurate. We built our objects layer by layer by heating the filaments of the material and building them layer by layer. Take home message: digital dentistry is cool. You have to think about this one. It's really a cool procedure, and we have to maybe next time if you think to make webinar. I would really like to make webinar for the starters, for the beginners. By the end of the webinar, that they will everybody at least will print his models for himself to make models, to start scanning and to make models for himself. I think it's a really a good idea to start. The most difficult step is the start. These are some recommended resources. I think the YouTube is the best teacher. I would say the best professor I learned from. This journal is very interesting. The problem, unfortunately, it's in German language, but at least if you have access and you see some pictures, it's very, very, very useful journal. I learned a lot from this journal. These are some recommended books. This book is very nice. And by the way, I don't know if he's still the dean of, he's in Dammam in Saudi Arabia, Dr. Fahad Al-Harbi. I don't know if he's still the dean of the college or not, but this book is very, very valuable. I send you warm greetings from Germany and thank you for your listening. Thank you, Mahmoud.
Thank you. Thank you so much, Abdulmajeed. It was very, very interesting and very informative lecture. I really like it. You went through different perspectives for digital dentistry, and you systematically presented the concept of digital dentistry. And I like it when you divide it for three main aspects, which is the computer-aided inspection, where we need to acquire the data. And in this case, we need to concern about accuracy and all these matters. And then you moved us to the computer-aided design, which is important because you need to design based on the acquired data, you need to design your prosthesis. And finally, you introduce us in more details to the computer-aided manufacturing, which is very, very important because in the end, we need to have the prosthesis go to the patient's mouth in a physical way. So thank you so much for the interesting presentation. And once again, I would like to ask the participants, don't be shy and ask. It's a great chance to have Abdulmajeed with us today. So his expertise in digital dentistry, and mashallah, he got a lot of qualifications in different aspects of dentistry. Even the sport dentistry, and we are about to have the match for Morocco. So I guess that's another interesting thing, and he promised us to present another webinar, so that's good, Abdulmajeed. We got that from you. So always there is a concern about the accuracy of the printed dentures, for example, when we talk about digital dentures, and mainly for the 3D printed, it's different from the milling. At least the milling has still high accuracy compared to the 3D printing. Do you think that in the future the quality of accuracy for the 3D printing dentures will be increased? Do you think that?
I think with the development of technology with materials, yes, it will happen. The biggest or the main difference between both of these technologies, with milling technology, we don't have polymerization shrinkage. We don't have this one at all nowadays.
Yeah.
With the 3D printing, it's not our concern is the shrinkage. It's not the biggest concern. The biggest concern is the accuracy of building these layers. This is the main concern. With the materials, with the introduction of new materials, I think it will, and it's indeed nowadays it's really accurate with the 3D printing, especially with complete dentures.
Yeah, why I'm asking about that, because for example, for obturators, it's very difficult to do the milling for the obturating because of the undercut and the access to the undercut area. So that's why I guess the 3D printing is still a promising way to have the obturator be available through the digital workflow.
Especially with obturators, like for example, we have the limitation with milling because the blocks or the rolling, I don't know in English what it's called. I think the blocks of the materials of the PMMA, it's limited. Sometimes our defect it's more than this limitation. That's why if we build up these materials, we don't have this limitation with the 3D printing. That's why the obturators with the 3D printing is, in my opinion, it's easier and more practical than with milling, especially in big defects.
Yeah, that's true. So I think we came to conclude our webinar today. So I would like to thank you, Abdulmajeed, for your time and effort to give us very interesting lecture, introduced us to the future of our provision. Also, I would like to thank all the participants for their time, that they attended this valuable presentations. I think we got something. So yeah, Ryan Al-Hamri, thanking you, Abdulmajeed, for the lecture. And for the participants, please stay tuned. We still have some webinars in the next few weeks, and we are going to have a new session for the 2023. So stay tuned and be connected to Digitodontics, so you will learn a lot about digital dentistry. So as a tradition, Abdulmajeed, we are glad to present you a certificate of appreciation. We hereby express our sincere appreciation to Dr. Abdulmajeed Okshah in recognition of his contribution as a live webinar speaker for the Digitodontics webinar series on the topic of digital dentistry, an overview from data acquisition to manufacturing, that was presented on Tuesday, December 6, 2022. So, Abdulmajeed, once again, I thank you so much.
Thank you very much, Mahmoud, for this invitation. And I think we are running out of time. All of the best for the Moroccan team. Now, when they'll start in 1 minute.
Okay, that's good.
I thank our participants for their participation.
Okay, thank you so much, Abdulmajeed. And yeah, as you said, we wish all the best for the Moroccan team. For their matches already, I think, started. So I think all of us will go to watch that one. So thank you so much and have a nice day.
You're welcome. Good evening. Goodbye.